All right, under the Arrhenius acid-base theory, what constitutes an acid? Kevin.
It gives you H plus when you put it in water.
Okay, so if the concentration of H plus increases when added to H2O. And it's very specific about the water, and it's very specific about the H plus. And what was the definition for the base?
It gives you OH minus.
If hydroxide ion concentration increases when added to water. Okay. How about the Bronsted-Lowry acid?
No, that's the one that donates H pluses. It's the other one accepts them.
And Lewis.
Substance, the acid, receives electrons, and the acid extends the electrons to the base. Donates them.
Accepts a pair of electrons to form a bond. Accepts. And then the base is when we talk about this donating, what happens when the bond breaks? What happens to those donated electrons? They go back where they were. They're only donated to make the bond. They're not actually, I'm not like, here's my car, NPR. No, that's not what we're talking about. It's, here, you can use this, and when you're done with it, I get them back. What's wrong with the Arrhenius' theory that you need two more acid-base theories? No need of water and H plus cannot exist on its own in H2O. Okay. Write a chemical reaction for any strong acid with any strong base. So
Sulfuric acid and sodium hydroxide.
Sulfuric acid, and the formula for that is
H2SO.
and what'd you say?
Sodium hydroxide.
Okay. Are we okay with everything I have written up there? Why is it aqueous for the acid? Because acids are soluble. Why is it aqueous for the sodium hydroxide? Because there's a group 1 metal. Why is it liquid for the water? Because it's water. Why is it aqueous for the sodium sulfate? Because there's a group 1 metal and there's a sulfate. So it's pretty soluble. All right, so acetic acid. I wanted the structural formula for acetic acid. I've drawn this several times for you guys. You, I think, built this one time. All right, so I've got 4 H's here, and which one's the acidic one? Now, there's only one H that's acidic, and it's going to be that one. So you can do a couple of things here. It could be as simple as which one of these is not like the other. It couldn't be these three here. If it was those three over there, then which one is it? Or you can say that this thing here, let's go with, how about orange? That this, whoa, hello, what was that?
It's a big one.
That was weird. Well, let's try that actually. Oh, that's kind of cool.
Cool.
So what do I have highlighted green there?
Acidic hydrogen. I don't know.
We got a name for that. That's the component of organic acid. Organic acid, that's what they look like. It doesn't matter what is to the left of that green blob. What's important is that carbon doubly bonded to an oxygen, bonded to an O, bonded to an H. Anytime you see that, it's an organic acid. So acetic acid is just the 2-carbon version of it. Methanoic acid would be the 1-carbon version of it. There are many, many versions of it. Okay. Any questions about this? Nay.